On this video, we want to understand the differences between switches and routers, which are two types of devices that connect networks and devices, but they do it in different ways. If you have seen the model of the internet architecture, you know that there's really two basic models used. There is the OSI model, which splits the internet into 7 layers, and this is a standard model that gets used while the TCP/IP model was the first implementation of the OSI model. So if you start noticing each model, the layers map out to each other. Application, presentation, and session goes under the application layer of TCP/IP. Anyways, the switch, for example, belongs in the data link layer of the OSI model, which maps out to the network interface of the TCP/IP model. That's why network cards are called network interface cards, or NICs, NIC. The routers work a layer above. In the OSI model, it's the network layer. In the TCP/IP model, it's the internet layer. That's why the internet gets its name, because it's the layer that connects faraway devices together. Now, let's start looking at the simulation, which is right now which is connected through a router, through router 0. If we look at the configuration in PC0, we'll see that its IP address is 192.168.1.2. Its gateway, it's another name for the router. It's 192.168.1.1. And you'll notice that the two addresses are actually very similar. If I look at the subnet mask tells me that, oh, this network is the 192.168.1 network. So since they're in the same network together, it's like they're in the same neighborhood. So that means that they're neighbors. And the router is the boundary. If we look at PC1 and we start looking at its address, we'll notice that it says 192.168.2. The router has an address of 192.168.2.1, or the gateway. And by the subnet mask, I can tell that they belong to the neighborhood 192.168.2. So this is a different neighborhood, and by my choice of words, you can tell that a router is a boundary that connects different networks together, or different neighborhoods together. So if I want to send a message from PC0 to PC1, from PC0 to PC1, I have to go to the router. So let's see that in work. PC0 sends the message to PC1. We go through each step. We're still in the neighborhood of 192.168.1. We get to the router. The router says, message not for me. And this is because the router right now doesn't have the complete map. It needed more time. I was trying to give it more time while I talked. So we try again, send the message. It reaches the router. The router now hopefully has a complete map and can send it to the next neighborhood. And it passes through. PC1 receives the message and can tell that this message is for me, so I'm going to respond. This is just a check saying whether I'm here. It's like, yep, I'm here. Here it goes back. The router has a complete map, and it can send it back to the other neighborhood, to the first neighborhood. And PC0 receives the message, and the message is complete. So the router is using the network addresses to connect these neighborhoods together. The computers also have a physical address. It's called a MAC address, and that's what switches use. But the physical address are only meant to be used within the neighborhood. So switches cannot cross over neighborhoods. They can only connect within the neighborhood. So let's connect these switches together and try to go there without making any changes to the computers themselves. So the computers still have addresses that belong to different neighborhoods. And the switches don't pay attention to that. So we're going to try and send the message again from PC0 to PC1. And let's see if it works. Goes to the switch, it goes to the neighborhood. He goes to this other switch that doesn't know that these computers are separated by neighborhoods, but it keeps moving along because, oh, I have another connection, I can send it here. PC1 receives the message, and even though it received the message, it looks at the network address and it never went through the boundary, never went through the router that should be in between these two networks, these two neighborhoods, and determines this message can be for me, even though it is meant for PC1, but it can't tell because of the IP address boundary was never reached. So that's the end of it. The message, it's almost like the message was sent and there was no response. That is the difference between a router and a switch. A router connects two or more different networks, while a switch can only connect within the same network.